What is the valency? The valency is the electrons in the outermost shell. The electrons in the outermost shell of an atom. And this electron, this valence electron, will predict whether this atom will lose or gain electrons. So whether this atom will tend to form a cation, a positive ion, or anion, a negative ion. That's why it is the combining power of an element will show us how this atom will react chemically with other atoms. And they are represented by the number of electrons in the outer shell. The valency of an element determine how many atoms this element will bind to form a compound. It can easily be known by the group number of the element. So the group number inform us with the valency. So group 1, the valency is 1. Group 2, the valency is 2. Why? Because the number of the group is the same as the number of electrons at the outer shell. For example, sodium. Sodium is in the first group. Okay. The atomic number of sodium is 11. So it will be distributed as 2, 8, 1. Two electrons in the first shell, 8 electrons in the second shell. And 1 electron in the outermost shell. So this electron is the valence electron. This shell, the outer shell, it contains 1 electron. So the valency of sodium is 1. And because it's only 1, so it will tell us that this atom, sodium, can lose 1 electron, forming a positive 1 ion. Will be sodium positive 1. The first information that we know from its group number. So a group number equal to the valency number. So the valency is the number of electrons at the outermost shell. And it will give us some important information. First, how this atom will combine with will combine to other atoms. So because sodium, for example, has only its univalence, 1 electron at the outer shell. So it can lose this electron, and that will allow it to combine with only one other atom. Okay? Because it has only electron to lose and give it to another atom, forming, for example, NaCl. Okay? While magnesium, for example, magnesium is in group 2. Okay? And the atomic number of magnesium is 12, which will be distributed as 282. What are the information that we will get from that atomic number? We will get that. Let's draw the electrons. Here 2, 8, and 2. The information we get is that the valency is 2. Why the valency is 2? Because the outermost shell has only 2 electrons, and these 2 electrons can be lost easily, forming easily forming a positive 2 ion. So magnesium will turn into a positive 2 ion. So because it has 2 electrons that can give them to another atom or 2 atoms. So if magnesium is going to bind with an atom which will gain 2 electrons, so it will be only 1 atom. If magnesium will going to bind to an atom that will gain only 1 electron, it will bind to 2 of them, such as, for example, magnesium oxide. Magnesium is positive 2, will give 2 electrons, 2 valency, and oxygen has 6 electrons in the valence shell, so it can accept 2 electrons, so its valency is negative 2, is 2 also. So the oxygen alone, one atom of oxygen can accept the 2 electrons that are lost from magnesium. But if magnesium will bind to a univalent atom, such as chlorine, so it will need to give its 2 electrons to 2 chlorine atoms. So again, so the valency is the electron in the outermost shell, and is represented by how many electrons can be lost or gained by these atoms. And it will give us some predicted information like what is the type of ion this atom will be converted to, okay? And how this atom will bind to other atoms, and but will bind to how many atoms, okay? And we can know it by the group number. Group 1 has 1 valence, group 2 has 2 valence, and so on. But the nonmetals, remember, the nonmetals, the valency is how many electrons this atom will gain, will accept, because they have nonmetals, they have more than 4 electrons in the outermost shell, so they can gain electrons. Like oxygen, have 6, so it can gain 2 more electrons, and its valency is 2, like magnesium, because magnesium can lose 2 while oxygen can accept 2. So oxygen can turn into an ion or negative ion, while magnesium can turn to positive ion. This is simply what is the valence. And this is very important to know it to be able to draw the structure and the chemical formula of a compound, and also to expect how this atom will react in chemical reactions. So you can simply, if you know that, you can simply complete a chemical equation. When we come to chemical equation, you will see that. So from group 1 to 4, valency is equals to the group number. So group 1, valency is 1. Group 2, valency is 2. Group 3, valency is 3. Group 4, valency is 4. But from group 5 to group 8 to group 7, okay, the valency equal to 8 minus the group number. So group 5, the valency is 8 minus 5, which is 3. Group 6, the valency is 8 minus 2, which is 2. Group 7, the valency is 8 minus 7, which is 1. That refers to how many electrons will be gained for these atoms, because the number of the group refer to the number of electrons in the outermost shell. And when the electrons in the number of electrons in the outermost shell is less than 4, it will lose this electron. So the valency is the same number of the group. But if the number of electrons is more than 4, 5, 6, 7, so the valency will be the number of the electrons that will be gained, that will be accepted by the atoms here. So if we have 5 electrons at the outermost shell, in group 5, they will accept 3 electrons. How many until they reach to 8? Okay. An exception is group 8. Group 8 is the noble gases. Noble gases. So they have no valency. Valency is 0. Why? Perfect. Because it has its outermost shell is full of electrons. So it has 8 electrons in the outermost shell. So it's very hard to turn them into ions to gain or lose electrons. Other elements in the other groups are trying to reach to the electron configuration of the noble gases. The electron configuration in the gases in the group 8. That's why they tend to accept or lose their extra electrons. So typical compound for group A is sodium chloride. For group 2, magnesium chloride, MgCl2. For group 3, Al3Cl, ammonium chloride. For group 4, silicon chloride, it's ICl4, and so on.